Well, hello, and thank you for joining me in the fourth lesson of starting Python, or Python for beginners, or just this lesson in learning to program using Python. Not necessarily that you are learning to program in Python, but you are learning how to program, and we're doing it via the Python programming language. Let's go ahead and start idle. And I mentioned in the last video that we were going to talk about strings. And string might sound complicated, and it's not. What we mean by strings in programming is basically anything that is inside of a quote. You already wrote a string, and you may not even know it. When we wrote print hello world, we wrote a string, and Python wrote a string back. This inside of the quotes, the double quotes, is a string. And in other programming languages, it's more apparent what is happening under the hood, such as C or C++. Each character can only be stored in the computer as a number. And this might seem like a problem, and it sort of is. We have this thing that for a long time that we've called Ascii, A-S-C-I-I, if you're wondering. And what Ascii is an encoding of numbers into characters. So we can tell a compute to print whatever character is a 65. And this happens to be the letter A, the capital letter A specifically. And this sort of is difficult to wrap your head around at first, but because computers only understand numbers. And more specifically, they only understand binary numbers. Everything else that we build on top of it is just mapping from one to the other and displaying what we expect to see. So we tell the computer when you save a file that has a letter A in it, if we were to open up that in a binary editor, a hex editor, we would see that it's just the number 65 inside of a text file. We might do that just to prove that that's really what's happening. And in a different video series I'm going to be working on, we'll take a different approach to this, but inside of memory in a computer, we do really only store numbers. And so if you want to store the hello world, what you're going to get is the numbers that are used to tell the computer to print the capital H, the lowercase e, the lowercase l, the lowercase l, the lowercase o, the space character, even the capital W, and so on. And this is the first part of why so many computer systems are case sensitive. Have you ever wondered when you type in your username why it cares if the first letter of your username is a capital or not? It's because a capital A is a 65 and a lowercase a is not. I don't have my chart in front of me, so I don't remember what they are, but you can very easily open up your Brave internet browser, which you can find over at brave.com, and just search for Ascii Chart. And what you're going to find, hopefully, is a bunch of pictures that show you the chart, the number that we store in memory in the decimal field, not hex. That's different. And what letter character we're going to show on the screen. And you can see here that lowercase a is 97, whereas the uppercase A, or the capital A, is 65. So when you type in your name, Aaron, and you type capital A, you just told the computer 65. When you go back to log in with your username, Aaron, and you use a lowercase, you're telling the computer 97. Now, is 97 and 65 the same thing? No. So the computer gets confused unless the programmers thought about this and they have programmed it to understand that 97 and 65 are the same when we're talking about strings. There are some common practices we could do. We'll go over them in some of the coding challenges later. But for now, they're not the same. And all letters are just numbers. All right. And in Python, there are ways to go between the two. And so if we say something like int a, it's just going to give us an error though. So if we're trying to say it's a invalid literal for int, unfortunately, this language doesn't make it as nice to say, well, I just want the number value of a, or I want the letter that corresponds to a number value for a string. So in Python, if we were to say, I want the string of 65, you would think that it would say, oh, well, that's an A, but instead Python thinks it's a little bit too smart for us and gives us the 65. Now this is quite handy when you are debugging and you want to see that number 65, so it depends what you're going for here. And we do have this ORD function though, and notice that that does give us the 65, how we want to see it for A. So it does give us what we're looking for. I don't know why we're looking for it right now, but this is just to prove that even Python, when we say we want the letter A, we want to know what its value is. Well, its value is 65, and if we want to see the value of that is stored on the computer of a lowercase a, then that is 97. And I mentioned in the last video that I thought strings were one of the most important features of programming, or one of the most important things we can do with programming. And the reason I think this is because all of our communication is based around the ability to write down strings of characters and someone else be able to read them and interpret what we meant. And the ability for a programming language to allow us to process that gives us the ability to automate a lot of things. The ability to eventually have good semantic analysis of languages, and to do sentiment analysis, or to figure out what someone's trying to talk about. Search engines online are because we can type strings of data, and it can parse strings of data, text that's on websites, and then from what we're searching, recommend websites. Okay, with that 10 minutes of rambling out of the way, I would like to actually get started using strings. Just as before, where we had variables that could contain the numbers, we have variables and they can contain strings. The same thing, if we want to say my name equals Don Duval, and if I just put my name again, only inside of REPL or the shell, can we just put the name or the variable and it prints it out. Inside of a script, we would have to say print my name. We're calling the function print, just like we called the function avg3 that we defined. We can call print, which we didn't define. It comes with the language. Give it the name of the variable and it'll print that out. Notice print does not include the single quotes around it. And it's just a nuance of how printing works inside of Python. There's other print functions that will include that. There's one called pprint. However, to use that, you have to do some extra stuff, which would be this. We want to say from pprint import pprint. Don't worry about that right now, but if I say pprint my name, because my name is a string, it includes those strings there. Now if I were to say my age equals 30, and if I say print my age, it'll go ahead and print it without the quotes, as expected. If I say my age, no quotes, and if I say pprint my age, no quotes, because it's a number. Numbers don't have quotes, only strings. Why they chose a single quote when you print it, I don't know. Because inside of their errors, you can see that here file, the PyShell number 1 has double quotes, which it put there, but then later it says base 10 literal A with single quotes, even though we typed it with double quotes. It's a little all over the place. Single quotes, double quotes, doesn't matter. The one thing is, if you want single quotes inside of your string, so if I want to say, let's say that house name, if my house were to have a name, which it doesn't, but let's say it does, we could say Don's place. And notice that I used the double quotes on the outside so I can have the single quote on the inside. And it prints it correctly, and notice it went ahead and put double quotes on the outside also, so it didn't have to escape the single quote on the inside. And if we reverse that and say house name equals Don's place with the double quotes like that, it accepts it, it's good. I put the single quotes on the outside, double quotes on the inside, and we say house name, it goes ahead and does it too correctly. The other way we can do this is if there's a character such as the quote that sort of breaks the Python's syntax parsing, we have what's called an escape character. And so let's say we want Don's place again, and I'm going to use a single quote on the outside, and notice how Don's, I left out the single quote in that last example because I have the double quotes over here for place. But if we want it to be really correct, we can do that. And now when we print it, ooh, that doesn't look good, does it? But if we use the print function, it fixes it for us. And so this is because it's printing out that when we're just calling the variable name, it's printing out the literal value unprocessed. So it's including the quotes. It's including the escape character also. But when we call the print function, it's going to print out the string that we want, what we meant, and that because we're going around Python's syntax, we have to add the escape character in there, but we don't really want to print the escape character. Sure, the escape character is actually in there, in the code, or in that literal, but we just want to print what the string actually is, not how we represent the string. And pprint on house name, and that gives us the same as just house name. Alright, this is how you escape the quotes when you want to use them inside of strings. We can assign a string to a variable, and we can also, as you saw, we can alter the variables by just giving it a new value. Something else we can do inside of Python is called concatenation. You can do this in just about every single programming language. So how this looks in Python though is so let's say we're going to call this Don's, and then plus, we'll add a space there, and we'll call it place, like that. And just like, well, not just like numbers, but we can use the plus sign to mean append or concatenate place to the end of the string Don's. And so if we go house name now, it gives us Don's place, as expected. So that's kind of cool. We're reusing some arithmetic symbols, or some symbols, to do things that, in English at least, when you say add my name and your name, most people would append their name to our name. Or if we say add your name to the list of attendees, people know what that means. So this is strings, and I feel like this video, or this lesson, has gone on long enough. Hopefully you understand the difference between the numbers and the strings and what they look like, and that we can store them in variables. We can do operations on them. And one last thing, actually. Let's go ahead and define a function, and we're going to call this one print bio. And we're going to take a name and an age, and we'll also take a weight. And what we want to do is we just want to make something that'll print out a person's information, just a bio. And we'll do this by calling print, and we'll say actually we'll just put name, and then we're going to add to name the colon here, and then we're going to end with that for this line, because print prints one line at a time. We'll go ahead and print age. And now something special here has to happen, because age is a number, and you can't add a number and a string. It's going to break. In the worst case scenario, it would automatically convert it to a string, because remember, when we have numbers and we want them to print as we did before, we use that str function, and it printed out 65 for the number 65 instead of the letter A. It's because Python's getting a little smart and saying, hey, I know what you mean. You want to take the number 65 and print it and show it to someone. So we're going to use that to our advantage here and say we want to print the number age, or stored in age, and show it to someone. And here let's add a couple spaces for indentation, and then let's do this space weight plus str weight. Alright, so all our parentheses are closed. It's looking good. We're going to press enter twice. That gets us back into our command prompt, or the REPL, and we can use this function now. And now what this function does is it takes 3 parameters, or arguments. I still need to look up which one's which. So if we call print bio, we need to give it a name, age, and weight of a person. So, and it's going to print them, hopefully nicely. So we don't need to call print. We'll just call print bio, and we're going to say Don Duval, and age 30, and weight, last time I checked, was 172. Alright, let's print that. And there we go. Don Duval, age 30, weight 172. And notice that we don't have it return anything here. This function in other languages might be called a procedure, because it executes code that does not return a value. The previous one, our AVG3, could be defined as a function because it takes some input, does some processing, and returns an output. Whereas this procedure takes some input and doesn't return anything to whoever called it. It just passes it to the screen to be printed, and that's it. So we would call this a procedure. And so here we have used strings and numbers together inside of a function. So if you are still struggling with functions, we're going to go over them. I believe we can go over them in the next video more extensively, or the next lesson. So we have done installing, we've done basic arithmetic, we have done strings, and we've done functions, and variables. Let's not forget variables. They're super important. So we've covered quite a bit of stuff already. Let's move to the next video, and we'll push forward with functions and how we might really utilize functions to do some useful things.